There we go. That's right. Yeah. Now you can hear me. No, you're completely inaudible. Wait, are we talking about audible? Well, maybe you should go to audible.com/Warrener Computer Science and get a 30-day free trial or something. Don't really do that. Audible hoped you've enjoyed this program. Yeah, so sorry about that sound thing. Basically, I changed my sound server, or I updated my sound server yesterday, and something doesn't matter. I just needed to update the device. Anyway, it's done now. What I was saying when you all pointed out I was muted was I discovered that salted cashews are a very good thing. So I'm going to consume those as we go through this video. Right. So it looks like there's only 12 of us. Nice to see people are so dedicated to their studies. I mean, peanuts versus cashews. I don't know. I like them both. But I've eaten lots of peanuts, and now I'm eating cashews. So variety is the spice of life. In terms of peanuts, though, salted peanuts, take it or leave it. Dry roasted peanuts are the pinnacle. What I'd really love is if someone made dry roasted flavour crisps. You know, the stuff on the... You put a dry roasted peanut in your mouth and you suck that flavouring off it. You know, anyway. Right, okay, anyway. Oh yeah, if you're allergic to nuts then that kind of sucks. But yeah, pistachios, yes. Now then, let's just quickly go through where we got up to so we can see how we're going to pull all of this together. So, just running quickly through all this stuff. I apologise if you can hear me, if the sound of me eating these nuts is like some horrible ASMR. We've got directions, yeah? Maybe I'll just stop eating while I'm explaining this. We created this list of directions, not to use it specifically here, but it means whenever we're checking to see what directions are actually valid, we can put it in here. Now, another thing that we could do is we could also have a list of valid commands. At the moment we've only got look, but later on when we add things like get item and stuff like that, rather than having a billion different elifs, we can just put them in a list of valid commands up here so that we can check that. Okay. Notice that the variable is the variable name is in block capitals. What does that signify? Does anyone know? The fact that I've written this variable name in block capitals, what does that signify? We've got two answers here. You'll use it multiple times in the future. Well, yes, but we'll use any variable multiple times in the future. It's constant, which means it's not going to change. And in fact, a better data structure for this, rather than using a list, a better data structure would be a tuple, which is kind of like a list, but it's immutable. You're not allowed to change it. So don't feel that you have to do that. But that should still work. Okay. So yeah, cool. Right. So just moving down, we've got our rooms and descriptions. I've already been through that in the last video. This is the bit where we link the rooms together, bearing in mind it is possible through this method to have one-way rooms. So you could link one room to another room in one direction, but not link it back in the reverse direction. I'll leave you to ponder the ins and outs of how that works. We've got a move function, which really all it does is double check to see whether we're actually allowed to move or not. I've had a thought of how I can fix that. Yeah, maybe I'll get onto that. Remember, we had some problems with it not working properly in the interactive shell. A flash of inspiration has just popped into my head about how we can fix it. But anyway, we've got show description, which basically just prints out the name and the description of the room. Or if you try and print out a room that doesn't exist, it's going to give you some error. Okay, what's that word beginning with V, which does all our error checking to make sure our program doesn't crash? Begins with V. Well, remember, guys, validation, excellent. You guys are on the ball, on the ball. Not vindication. That's something entirely different. So we're going to read input. And remember, all read input does, yes, it takes the user input, so it asks the user, what do you want to do? But then it also does a little bit of validation on that input. And it either returns what the player input, or it prints out an error message saying, I don't know how to do that. Okay. Now, at the moment, the only command that we've got is look, but if I added more commands, I would put them in a constant right at the top of the file, and I would have elif player input in commands or valid commands or whatever I called that constant. Does that make sense? Yeah. Just say no if it doesn't, but I'm going to carry on. And then I will go back and answer questions if necessary. We've also got process input. So two functions. One reads the input, the other one processes the input. You could have a single function which reads and processes the input, but it's a good habit to get into to make your functions do one specific thing. Okay, if you make your functions do one thing and do it well, you can combine those functions together, and that makes it a lot easier to find out where errors are going. Okay, so we've got two functions, read input and process input, and all process input does, it checks to see if the command is a direction, because if it is, we've got one way of handling it. Otherwise, The only other command that we've got at the moment is look, but we would probably have another if statement, which is for the what's the word I'm trying to use? The actual commands. Okay, so look or get item or fight or whatever. Okay, we would also probably, if we expanded on this, have multiple functions for the different things. Okay, rather than just having show description player pos for the look, we'd have, if it's in commands, then we'd execute a certain function based on what the command was. Okay, so at the moment, if I run my program, it doesn't actually do anything because we've defined all of these functions, but we haven't actually called any of those functions. Right, just bear with me a second. I need to sort something out. No, that ain't gonna work. Got to do it the long way. Cool, and we're back. Right. So, are we ready to actually pull this together into something that resembles an actual functioning game? I'm going to show you a little bit of pseudocode. Okay. Let's comment that out. Can you all see that pseudocode all right, yeah? While game is running, display location information, input player commands, process player commands, right? Any game that you play, just imagine that you're playing Monopoly or Ludo or some other classic board game, right? The way that these games work is you have a number of players, and usually you have some pieces on the board, and there's a set process that you go through, right? When it's your turn, let's do something simple like snakes and ladders, right? You all know how to play snakes and ladders, yeah? When it's your turn, what do? You roll the dice, and then you move your piece, the number that you rolled on the dice. If you land on a square which is at the bottom of a ladder, you move to the top of the ladder. And if you land on a square which is at the head of a snake, you move to the bottom of the snake. And that's the end of your go. And then it's the next person's go. And what do? They roll the dice, they move their piece, the number that they rolled on the dice. If they land at the bottom of a ladder, they move to the top of the ladder. If they land on the head of a snake, they move to the bottom of the snake. Okay, and then it's the next person's go. And it's the same thing. You're doing the same thing over and over. Okay, even if you were playing Snakes and Ladders on your own, so it's just you and no one else, it's probably not the most thrilling game, you would still go through that process, right? You would still roll the dice, move your piece, the amount rolled on that dice. If you land at the bottom of a ladder, you move to the top, and if you move to the on the head of a snake, you move to the bottom. Okay, and you do that until the game ends. So while the game is happening, you go through that same process over and over and over again. And every single game that exists can be boiled down into those steps, right? You input commands from the user. You apply whatever the rules of the game are based on those inputs. You update the position of the pieces in the board or on the screen, okay? And then you move on to the next person and you do the same again, right? Even real-time action video games are absolutely no different, right? You're still doing read the player's input, move his pieces according to the rules of the game, yeah? Update the position of everything on the screen, draw the screen. Then it's the computer's go, if you like. read his input, move the things according to the rules of the game, reposition the things on the screen where they need to go, refresh the screen. Okay, it's absolutely no different. It's just in a real-time action game, the computer doesn't wait for you to finish your turn, and every turn lasts a 60th of a second, or a 30th of a second if you're playing on console. Yeah, hang on a minute. I messed up the delivery of that joke, but I think I can fix it. There we go. So let's just rewind. Imagine I didn't actually say that, and I say, so each turn lasts a 60th of a second or a 30th of a second if you're playing on console. Yes, right. That's a thing which is going to happen from now on. I hope you all enjoy that. Now then, does that make sense? What I've explained here regarding the way that the game is going to be processed. Like, this literally goes on and on and on until the game is over. So that's until someone wins, or everyone gets bored and turns it off, or flips the board over, or or whatever. Does that all make sense? Are we ready to actually try and implement this now? Excellent. Right, so I'm going to leave that pseudocode up there because it's a useful thing to have, and it will guide us in the process of what we're actually going to do here. So we need a while loop which is going to run while the game is running. So obviously we need some sort of variable that's going to keep track of whether the game is running or not. It's going to be true or false. What type of variable is that going to be? What is the data type of the variable which is going to be true or false? Boolean. Boolean. Yeah, okay. So we're going to have something as simple as game, not capital letters here, game underscore running equals true. Boom. There we go. Not minus true. There we go. Equals true. So we now want to say while game running. Now we could, in my example code, I think I did this. Equals tree. I could do that, right? But we don't need to put the equals true, because basically the way that while loops work, it says if this statement here equals true. The equals true is always on the end there. So what we're essentially saying here is while game running equals true, do this stuff. And we're not one for tautologies here, so we can just get rid of that, because what this is effectively saying now is while game running equals true. Okay? Python does use camel case for class names, by the way. I'm sure there must be some Java snake case. I just want to see if there's any. I'm going off on a tangent based on something that Tommy has said here, which is completely Java. Yes, snake case is used in Java for static final constants and enum values. There you go. Anyway, let's get back to the task at hand. Now, it's nice to have these little diversions. It keeps things interesting. So while the game is running, first of all, we want to display the location information. Well, that's easy. We've already got a function to do that, right? So we're going to show description. And the description that we're going to show is whatever our current position is. Now, we have a variable that handles that. Boom. So right off the bat, because we've already written the functions to handle this, piecing them together, we actually hardly need to write any new code because the functions handle their own stuff. We're basically saying, do that thing that I told you how to do already. Okay, so there's our first bit done. Display location information done. Input player commands. Well, we've got a function that does that. Now remember, our read input is going to return either a command if it's valid, or it's going to return false. Okay, so what we're going to do is we are going to say if no, we're not. We're gonna say player command equals read input. Okay, so that's going to read the input and it's going to store the command in this variable. Now that command is either going to be a valid command or it's going to be a it's going to say false. So now we can do this. If player command equals true, then we know we can actually process that command. If player command is false, we know that they've entered an invalid command. Yeah, so we do not pass that command to process input, because process input doesn't handle bad commands. It assumes that the command you give it is already a valid command. All of our validation happens in read input. Okay, so if player command equals true, we are going to then process the input and it's player command. And that's it. That's all we need to do to get this show on the road. I'm just going to edit my my run configuration here. Just bear with me a second. I'm going to turn off the Python console. Should we give it a go? Let's give it a go. Control Shift F10. Here we are. Inside the log cabin. You stand inside a cramped but cozy log cabin. The smell of wood smoke hangs heavy in the air. A door stands in the south wall of the cabin, allowing access to the outside world. What now? So we're at this point. Okay, let's see what has happened. We have started the game running, and now we're inside the game loop. Okay. We're showing the description, so that's this. All of this text here comes out of show description. And then we've got player command equals read input. Okay. Now, some of you have asked about what goes on with the functions. Okay, how does the flow of the program change according to the function? So I'm just going to give you a quick example here. I think I already explained this in some detail with the stuff that we did on logic gates. Okay, but let me just sort of explain what's going on here. In fact, it might be easier if I just get a screenshot of this. I'm going to use my imaginary whiteboard. Okay, right. So let's just get this on the screen here. We are going to add a window capture. Okay. Right. Here is my. I'm using GIMP as a whiteboard here. Hopefully, you all can see that. Yeah. Let's sort this out. Just need to change the size of that brush there. Cool, right. So let's say we are currently here, right? We've reached this point here. Obviously, I'm skipping ahead a little bit because this allows me to show everything that's going on anyway. Right, so if player command, well, player command is true, so we are now at this point here, process input. Right, at this point we have said run this function, okay, and the data that we are passing to that function is whatever's stored in player command. Okay, so what happens here is the code jumps from this point here all the way up to the start of that function, right? And this player command, that data, that goes with it, yeah, all the way up here, and it gets stored in this variable here. So effectively, command, that variable, is whatever was stored in player command. So if player command was look, for instance, let's say player command is look. I apologize for writing with a mouse. It's the worst thing. And this color choice is probably not the greatest, but yeah, what are you going to do? So command equals look. Okay, now because we've passed the data, right, player command is still look, but we can do whatever we want to it in the function. So at the moment, the program has jumped from this point here all the way to the top of the function, and it has passed this data. It doesn't actually pass the variable, it just passes the data. So the data comes up, and then it's stored in a temporary variable called command. Right, so now, if command in directions, well, command has been assigned this value look. So we're saying if look is in directions, well, directions is all of the compass directions, so we know it's not. So now we're going to skip over that, and elif command equals look. Well, command does equal look. So now we're going to call the show description function. Now, if I actually had a big enough screen, I would show that at this point the program jumps all the way to wherever the show description is, and player pos is that global variable, which is kind of a bad idea, which is then sent up to show description. Once show description has run, that the code then comes back. If I just say show description, okay, once we've finished running show description, the code comes back to this point here, okay, the line after that function call. And now, because we're done with that process input function, okay, after that what happens is the code then goes back to the line after that. Okay, so after the function call. We're now at the end of our game loop, so what happens is we loop all the way back up here, and the process goes on and on. Okay, does that make sense? What's happening with the flow of the program there? Okay, our function definitions basically show us how to do a specific thing, right? But that code is not executed until we actually call the name of the function. Okay, I'll pull another video together with some very specific examples so you can see what's going on here. Okay, but for now, let's boom, and we will go back to that. Let me just get rid of my no, I want to discard those changes. Don't need those. Okay, so let's get back to our game. So what now? We are now at this point here. Okay, we are at that point there. We are currently executing line 81. And to answer your question, Tommy, it's literally the next line. Once you have, once the player has entered their input, we take that input and then we convert it to lowercase. Okay, I will show you how this works using the debugger in a second, right? But for now, let's type in our command. Well, let's say I want to go north. Right now, north is not in our list of directions. Okay. So what's happened is what has happened? If player indirect, we're going to return player input. Otherwise, print. Wait a minute. Where's that Karen description coming from? I remember writing. Oh, there we go. Oh, it's under process input. So it is in our list of directions, but it's not in the specific directions stored in the room. So it returns player input. So it will return n as player input, and then we get back down here if player command. Well, player command is n at this point. It's then going to process the input and it's going to send player command. So we're effectively saying process input n. So we go back up here, we're processing that input. If command in directions, well, it is. Okay, if command in rooms player pos dot keys, it's not. So we're going to print. You can't go that way, for God's sake, Karen. Okay, now. Because there's nothing here which actually stops the game running, this is going to carry on forever and ever. You can see I can move south here, outside the log cabin. You're outside a log cabin, high in the Swiss Alps. Although it is the height of winter and the peaks all around you are blanketed in snow, the bright sunshine feels warm on your skin. A narrow path extends to the east and west, following a mountain stream. What now? Well, let's go west. Why don't we go west? You know? Can you west? Yes. Wait a minute. Let's do that again. Can you west? Yes. There we go. Yeah, this is like the worst thing you've ever seen. We're now at the precipice. You follow the path to the west as it follows the stream downhill. Abruptly, the path stops and falls away sharply. Peering over the edge of the cliff, you watch the water of the stream plunge into the white haze several hundred meters below. What now? Jump off. Now, of course, jump off is not in our list of commands. And so what our program does is it says, I don't know how to do that. Okay, so I don't know how to jump off. And there we are, we're back in the precipice. Let's go east this time. Kanye East. That's Kanye West's worst enemy. Someone that can actually produce quality music. Let's go east again. Here we are at the cable car station. You're in front of a cable car station. It looks as if it was built centuries ago. The huge wrought iron pulleys straining as they relentlessly pull cars up and down the mountainside. To the west, a path follows a small stream down towards a log cabin. And that's it. We've explored this entire game. Right? Early access, what are you going to do? You know, it's barely complete, but you know what? I didn't spot any bugs in it. We could try typing in a whole bunch of stuff. Is that I can't really think of a way to break this. It doesn't know how to do all that. What happens if we just type in enter? Nothing at all. What if we do exit open brackets close brackets? It doesn't know how to do that, right? We have put enough validation in our game so that it ain't going to crash regardless of what the user does. And remember, the users are the worst thing. Programs would be brilliant if it wasn't for the users. There's a special name for the errors that occur when users do something that they're not supposed to do. I mentioned it in the previous video. Can anyone remember what it was? We got syntax errors, you know about, and semantic errors we've looked at. But the third type of error, which is caused by the user, can anyone remember what that type of error is called? It's not that. I mean, sort of user error, but it's not. That's not quite the same. This is very specific. It means because user error could be that the user's just using the thing wrong, but this type of error means that you hadn't anticipated that the user could use it wrong. If that makes sense. I'll give you a clue. It's 2 words. So we've got semantic error, syntax error. Those are both one word, right? This is 2 words. Something something error. It's a error. It's straining the old memory cells here. Can anyone remember? It's not invalid McIndex. Each word is 1 syllable. First word begins with R. Not range something. Good guess, though. Let's see if... I'll tell you what, I will give you an audio clue. I'll give you an audio clue for the second word here. Here's an audio clue for the second word. Can you all hear that sound? What if I crank the volume up a little bit? This is the second word. Second word begins with T. Not tick, but what device makes a ticking sound? Yeah, it's a clock which is used to measure time. Time is the second word. The first word is 1 syllable and it begins with an R. And these are errors that occur at this time when the game is... Man, these clues, This video is 12 hours long. 12 hours of ticking clock sound. Let's turn that off. Any ideas? Runtime error. There we go. Well done, Tommy. Yes, it's a runtime error. Good guess with read time and rest time. They're called runtime errors because the time when they occur is when the program is run. Okay, so a runtime error is something that occurs when the program is run, which it's not related to your syntax. You know, you've got your syntax right, your calculations are all correct as well, but there's something that happens when it's run which you hadn't anticipated. Okay, things like, for instance, divide by 0 errors. If you've got a calculator program and you and the user tries to divide by 0, you're going to get an error. That's the classic runtime error. And the way to avoid runtime errors is through proper validation, anticipating the sorts of inputs that users are going to make to their programs and thinking, right, if the user does that, how is our program going to cope? What happens when the user does that? How do we avoid the program crashing? How can we give useful messages to the user? Okay. Now, before I set you a task and let you go and work on your games, I wanted to show you how the debug mode works. I don't know if I've ever shown you this. Debug mode allows you to step through your program step by step, okay, using something called breakpoints. Now you might have noticed that when you click next to these numbers, you get these little red circles and the line gets highlighted, and you probably thought, oh god, what have I done? You click it and it goes away and you stop panicking for a little while, right? But what those red dots are breakpoints. What a breakpoint is basically you saying, run the program until you reach this point and then pause. Don't stop running the program, just pause so that I can have a look at what's going on and step through it and see what the current contents of all of the different variables are. Okay, so what I've done here is I've added a breakpoint at line 115. So as soon as we in fact, I'm going to add it here. As soon as we reach line 116, just before we show the description, the game is going to pause and it's going to wait for us as the user, or the developer, I should say, the debugger, to do something. Okay. Now the way that you enter debug mode, next to the little play icon, there is a little bug icon. And Control F9 is the keyboard shortcut, or you can just click on the little bug there. And what happens is it will run the program. You can see here it's got down to this point and now it has paused. Now this allows you to do various different cool things. It tells you what all of the currently stored variables are. Okay, you can see I've got a game running variable and it's set to true. I've got an I variable which is set to 3. That's from our game loop, our creation loop all the way up here. Okay, and I've got player pos which is set to 0, and I've got my list of rooms there. Okay, now you can switch between the debugger and the console, although it's better to switch between the debugger and the run output. If I switch to run, it should... Nope, it hasn't. Oh yeah, because we haven't actually run that command yet. So these buttons at the top here allow you to step line by line across your code. This one's probably the most useful one to you. Step into my code. It will basically allow you to follow the process of your program. So show description, player pos. If I click step into my code, you can see we've now instantly jumped up to the show description function. Right? It's even told us what the current value of room is there in our code, and we can see now that the value of room at the moment is 0, and all of the other variables we don't care about them right now, because the only variables that exist in terms of the scope of the function are the ones that are defined within the function. Okay, so we can carry on stepping through this stuff. So if not 0 less than or equal to room less than or equal to len rooms, well, we know that room is 0, so we should step into here, and sure enough, we should step over there because it's not, and sure enough we step into the else thing here, and it says print rooms room name. Okay, the other cool thing about the debugger here, the color of the variable tells you whether it's been changed or not changed since the last time it was viewed. If I click step into my code again, we should now, when we go back to the run box, have some output, except for some reason we don't. I don't actually know why there. Oh, no, because it's in the console. There we go. Inside the log cabin, you can see we've printed out that name. Right. Next up, we're going to step into my code again. It should have printed out another blank line. There it is. Okay, and then we're going to step into my code again. And you'll notice now we're back down here because we just ran the last line in show description, and once we've done that, we return back to where we were. Okay, and you can see we've executed all of that stuff. And you can see as well, we're back out here. All of the variables are there. I can keep on stepping through this. This is actually a really useful tool for you to see where the program is jumping to, so that you can find out where errors might be and stuff like that. Now you'll notice here it's asking us for input, so I have to go back here. What now? Let's try and move south. If I now go back to the debugger, you can see player input is S. Let's keep on stepping through here. Because now we can see that we have player command is S. I'm not going to bother going through the whole of this program with the debugger. That's something that you can experiment with. Okay. So Max has just asked the question. I'm just going to stop the debugger now. Max has asked the question, how do you get the loop to stop? Well, remember, the loop is running while game running is true. So if you want the loop to stop, you just set game running to false. Now, one thing to bear in mind is that if game running is set to false, if I set game running to false here, it's not going to instantly exit the loop there. It's still going to run all of these commands until it gets to the bottom, and then it's going to exit. Okay, but all you need to do is set game running to false. It's generally, I mean, if it's something where you're anticipating your player dying, it's then you need it should happen at the end of the game loop. The other thing to be careful of is if you are setting game running to false in your process input function, right? You will have to do this. If you want to set the value of the global game running, you'll have to write global game running inside your function. I assume, Max, that that when you set game running to false, you set it in process input rather than inside the game loop. And if you do that, then what that's going to do is create a local variable called game running, which only exists inside that function. Okay, so I mean, generally speaking, global variables are bad. What you should do really is have the process input maybe return a value which is called like quit or not, and then you can have some check inside your game loop. But as a quick fix, just putting global game running in your process input will allow that functionality to work there. Okay, so there's obviously way more that we could put in here. We could have items that sit in the rooms. We could allow the user to interact with those items. Okay, that is an exercise that I want you guys to experiment with. So your mission is as follows: aim to get just the basic game finished. Okay, minimum of 4 rooms, but feel free to go crazy. Have as many rooms as you want in there. You could maybe experiment with those one-way rooms and stuff like that. You could even have teleporters in there as well. I'm not going to tell you how those teleporters are going to work necessarily. That's something for you to figure out. Okay, so you're going to be making your own games based on this code. The only thing I'm expecting from you is a working game with at least 4 rooms in there. Okay. Now, if you want to go further, what you can try is adding additional commands. Okay. You can also you could maybe have variables that keep track of your score and stuff like that. You could see if you can get colored text working. So instead of everything just being black and white, you've got some color in your descriptions. You could even try putting some rudimentary combat in there, maybe with some dice rolls or something like that. Okay, but If you save the working version of the basic game, okay, send me that. And if you try extra stuff and it doesn't work, feel free to still send me the broken code telling me what it was that you were trying to do and the steps that you made towards that goal. Okay. I'm not expecting anything from you until next week. So that's basically that. Has anyone got any questions about what they need to do, or anything else? Ding, 360-degree video. What's that? There's a weird mode on here. What happens when I return quit? Well, you'd have to handle something with that. Remember, if you are returning a value from a function, then it allows you to assign that value to a variable, right? So you could do something like this, for instance, result equals process input player command. Now, most of the time that result is going to be nothing, but then you could have something like if result equals quit, then game running equals false, something like that. So what happens is process input is going to return either nothing or it's going to return quit. If it returns quit, you set game running to false. Maybe you could print a game over message or something like that. Okay. So, am I going to play the games? Yeah, I will. Maybe Monday's stream. Let's have a look at that. So, see if you can get me something by Sunday. If you don't want me to play your games, then let me know. But if you do want me to play your games, then let me know. If there's any specific sound effects or background music that you want me to put on while I play your game, then let me know. When I try to enter a direction, the room's playerpos.keys thing makes it break. The special variables don't show up until after it's broken. Yeah, you need square brackets. You need square brackets around playerpos, not parentheses. Yes, because you are accessing an index in the list. If you want more clarification on what's going on there is a video on my channel. I can get you the exact link to the video. Bear with me 1 second. Python. Let me find it. There we go. That was my voice. Did you just hear that? I went, I will post that. There you go. There is the link to the what's it called? How do I make a Python.exe window take up the whole screen like an actual game? It on Windows, it's probably like not enlarged full screen. I don't know if you can do that because it's running through a Windows terminal. You're constrained by the restrictions of the applications that you're running it through. On Windows, you might be able. There might be some settings in the start command that I showed you how to use. But if you want to get like proper full screen stuff, you're probably going to have to use some sort of graphical application API in order to do that. So that's that. Also, it should really be a player preference whether they have it full. I know if I was playing a text adventure, I wouldn't want it to be full screen, at least not without resizable text. I'd want it in a window, just so that I can resize it and make it easier to read. If anyone wants any tips on text adventure games that they can play for fun, I have a whole ton of suggestions of some of the very best. The ones that I recommend above all others are Slouching Towards Bedlam and Anchorhead. Anchorhead, in fact, is one of the best text adventures I've played in a long time. Some of it's fairly recent. But some of the older ones are also very good. A Mind Forever Voyaging is a great sci-fi adventure, and The Lurking Horror. If you're into Lovecraft and that sort of stuff, The Lurking Horror. I think it takes place in on the MIT campus. It's actually pretty good. But I'll put a link up in the Discord channel to those games, and also a link to the program Gargoyle, which allows you to run them in all of their glory. And when I say in all of their glory, I mean the program allows you to have some nice looking fonts, so it's not just your normal computer output fonts. Okay, that I believe is that. If there's no more questions, I'm happy to call this one done. Is that all? Is that all good? Yes, says James. Thank you, James. Okay, well, have a wonderful weekend, everyone. I'm looking forward to reading your amazing creations. Be totally creative with them. Some of you might want to look into having additional characters and potential dialogue options. That's going to be a real challenge, but feel free to try that out. Shout if you need any help for whatever reason, and if your code breaks, try and fix it, and if you still can't fix it, send me a message saying that it's bust with your code as well, or if you're getting an error, send me the exact error that you're getting, because that will help me diagnose what's actually wrong with it. Just saying it doesn't work isn't really much help, but if you say I get an index array out of bounds error or something like that, you know. Okay, thank you very much, everybody. Go and enjoy yourselves. The weather is kind of cold, but don't let that stop you.